to detect patterns. So when, and by the way, you can apply this to face analysis, face pattern. So when I looked at this problem of our voting problem, here I found myself in a very interesting situation. Here, as a mathematician, the guy with 4 degrees who's an expert in pattern analysis, but also a victim of what appeared to be election fraud, I had to use my own rocket science to discover this. So what did I do? I found a very interesting signal. In one of the counties in Massachusetts, Suffolk County, we were very lucky. In math, we call this a unicorn. We saw a very interesting pattern. We saw a pattern of high, low, high, low, high, low, high, low, okay? Meaning votes, Suffolk County is predominantly Democrat, very low number Republican. So I was able to find lots of precincts where I only got 1 vote, lots of precincts where I only got 2 votes, lots of precincts where I only got 3 votes, lots of precincts where I only got 4 votes, lots of precincts where I got 5 votes, and so on, okay? And I grouped those precincts on the y together. On the x-axis, you're going to see the votes. How many precincts did I get? 1, 2, 3, 4, 5, 6, 7, 8 votes. On the y-axis, the actual precinct counts, okay? And it's called a frequency. It's called a histogram, okay? Some of you may know what these are. And this is a histogram here. So what we're looking at is, this is a chart of my vote distributions histogram. You notice they go up, down, up, down, up, down, up, up, down, up, down, up, down, up, down, up, down, okay? And when you look at it, there's at least a row of 9 highs and lows, okay? Now, what's more interesting is it's 2 times more odds than evens. Let me explain that. This would be like you going to a table in Las Vegas. Every time you roll, a dice, let's say 6 numbers on a dice, imagine that every time you roll, you get double the number of odds than evens, okay? Which means a dice maybe has, 4 evens. Double the number of odds to even. So it's got 4 odd numbers to and only 2 even numbers, okay? Very unlikely, because it should be about 50%, 50-50. But this was double, okay? More odds than evens by double. And not only that, it was in a high, low, high, low, high, low pattern, okay? Up, down, up, down. So you're getting highs and lows, highs and lows. So what I did was, and anyone can do this if you know a little bit of math, a little bit of how to use Excel, basic statistics. We figured out, well, how would you get that? So we did what's called a simulation. You can do this. It's basic statistics. And we simulated the actual votes in Suffolk County. See, here's the actual votes, 4,245 votes I got. This guy Koch got 6,351 votes. Okay, so the total votes. And we simulated 100,000 iterations of this. Okay, in fact, I think we did. And what you see is this can only occur, that high-low pattern, 1 out of 161 times. You say, well, 1 out of 621 times. So 0.16%. Okay, you say, well, that's still a possibility. But then we did the high-low combined with the fact it was 2 to 1, right? Double the number of odds to evens. Well, what you see, and again, we simulated the same thing, simulating the election. What you get is this can only occur 1 out of 100,000, 0.001%, okay? So what we had discovered was this was an anomaly. Oops, I didn't share this. I'm sorry, guys. I share these slides, okay? So to the people in the YouTube world. So what you see is here's the graph, up, down, up, down, up, down, high, low, high, low, high, low pattern. First simulation, just looking at high lows, we found out this is 1 out of 621 elections, possibilities, 0.16%. But when we look at the actual data, it was not only was it high, low, high, low, high, low, but the highs were double the number of lows, 2 to 1, okay? And what you find out, this can only occur 1 in 100,000 elections, 0.001%. That we haven't even had that many elections in the United States since 1776, okay? So that's what this shows. So we had unequivocally shown that we had found a unicorn, an anomaly. And typically, this kind of anomaly, when you have lots of votes, gets hidden in the decimal side. But we got very lucky here. So what did we do? We went and we literally, let me go back to here, make sure I switch to you guys. We went and literally said, how could you get this? Well, the only way you could get it, check this out, Because remember, you have to get a pattern: 1, 1, 2, 3, 3, 4, right? Double the number of odds, 2 odds to 1, 1 even, 2 odds to 1 even, 2 odds to 1 even, and so on, okay? And what you see here is the way you can get this, if the original value was 1, 2, 3, 4, 6, and you multiply it by 0.666, okay? So we back calculated the weights, because this is the only way. The actual vote was here, and this is the weighted vote, okay? That's what we get. And the other guys was multiplied by 1.2. So we redid the entire election, okay? We redid the entire election. So the red here was me, what was called with the weights, and the blue, this is what they reported to the media. He got 57%, I got 38. But when you actually reapply, or you de-weight it, I actually got 52% and he got 43%, which, by the way, is the same percentage I got in Franklin County, okay? And then we did it in Norfolk County, okay? You see, very similar. So I win 54 to his 43. I win here 47. I win here, yes, 48. It was very close here, 48, 47, okay? Here you see it's 52, 45, I win. Here it's 54, 42, okay? And so on. So when you de-weight everything, I win the election, okay? This is de-weighted when I win. So after you unweight, I win by nearly 20,000 votes, okay? That's what actually took place, all right? Now, so in my second lawsuit, so by the way, my second lawsuit it's called a one person, one vote lawsuit. And those of you want to support it, go to vashiva.com/one-person-one-vote. Okay, you can find it. But in that lawsuit, I've asked to decertify the entire election. I gave all of this mathematical analysis. All of this has been submitted to the courts. This was about a month ago. Almost a month later, or a month and a half ago, a month later, the Secretary of State filed an opposition to my second lawsuit. They asked it to be dismissed. Let me just tell everyone, remember, in every other lawsuit Trump has filed, they've all been dismissed. I think close to 80 lawsuits dismissed. So they try to dismiss this lawsuit. They got all their 3 Harvard lawyers, or 4, how many ever people, they filed a motion to dismiss, a big, 100, 200-page motion to dismiss. Guess what happens? The judge denies their motion to dismiss. Second victory. Okay, he didn't give their motion to dismiss. Most judges have. Every Supreme Court, every federal judge, every appellate judge has dismissed every one of Trump's lawsuits. My lawsuit has not been dismissed because I'm going after the real crime scene. All right, and I'm not a lawyer, okay? I'm representing myself. So here's what we find. So in my second lawsuit, the Secretary of State, and this is, you're going to find out how criminal they are. Look what she wrote. The Secretary of State wrote, I have confirmed with the vendors of the ImageCast and DS200, that's Dominion, voting equipment, that the scanning functionality was disabled for September 1st state primary and November 3rd general election, and that no ballot images were created. Okay? She is saying no ballot images were created. Do you know what a lie this is? Why is this a lie? This is a lie because without ballot images and electronic voting machines, you can't count a vote. You need ballot images. Without ballot images, there's nothing to count. How do I know that? Can I back that up factually? Sure. Let's go right here. Okay. I'm going to share with you right here. This is from the affidavit of an election commissioner in Tennessee, where this is in the actual manual of the Dominion system. It says ballot images auditing capability retains a secure digital image of every ballot. And then this is a testimony of Eric Comer, one of the executive vice presidents at Dominion. They asked him, and this is what he says. He goes, regardless of whether it is hand marked or the QR ballot, the scanners first take a digital image of both sides.